Mm, okay, let me share my screen. Before that, um, so have you installed the Visual Studio Code in your laptops or not? Yes or no? Have you
Yes,
installed
yes,
the
we do.
Visual Studio Code? If not, you can ping me personally. I would connect with you, and if you're facing an issue, we can resolve it. Okay. Okay. So after you are able to install this Visual Studio Code, and you can try to download and install the any one of the Python version also. Okay. Okay. Let me share my screen. Hmm. I hope you can see my Visual Studio Code. If I'm wrong, hmm?
Yes, yes.
You can write. Okay. Cool. Okay. Good. Good enough. Okay. Now my point here is very simple. Let me hide the video panel. And I would like to open the folder, the thing what we want to be explained, and we have to save that particular area. Open the folder, and so everything I want to make it desktop, ML part, right? Okay, so here I would in desktop I would like to go with, or else in engine itself I would like to go with hold the dev loading projects or control shift, and I'm creating the folder here. The folder name is activation activation functions. Here I would like to explain about activation functions, the code part. Okay. So yesterday I just explained that what exactly the activation functions, what are the activation functions are there, and what kind of scenario we can use it. That I explained, right? Now, what is my action for today's thing is I would like to go with creating the some a code, or else here I can change the folder name also. Okay. Because which is practice code and all. Okay. So let me go over creating on a Jupyter file. To creating the Jupyter file, we can click on the plus symbol here. And generally, when we are really working on the projects, and make sure that you should have environment. Okay, so first you need to be go with creating the environment. Environment means like you might be work with Python 3.11 version, or you might be work with Python 3.12 version, or you might work with 3.14 something else, right? So when you're start working with the new projects, and make sure that you have to maintain environment, because even though you are uninstalled your global Python version, so the environment, if it is keep in your folder, then your projects, your code will work efficiently. So that is the reason we have to maintain the environment in Visual Studio Code. How do you create the environment? I can use the terminal. Here we have a three dots on the right. You can click on the terminal and click on the new terminal, and which is opens the terminal here. Okay. Now what you do here, you have to create the environment. Currently I'm using Python 3 point. Okay, Python version. If I want to know that what version I'm using, just simply click on the Python, then it will give you, it is entering into your Python shell. Okay. So I'm using Python 3.11 actually. So to come out of this particular shell, we can use the exit function. And now you're in a PowerShell. So PS indicating that it's a PowerShell. It's a terminal. Okay. So there we can execute the Linux commands also. No, sorry, commands actually. So now I want to be go with creating the environment for Python 3.12. Python for creating the environment, we can use the Python followed by the hyphen m. Okay, and we can use the command is v and ve, and so every environment, every Python environment, you can start with the dot actually, because it could be in the top of the position. So you don't need to be go with search maybe within the same folder you might have the multiple folders also, right? Okay, to make it in the first position, then we can use the dot. And so this is the deep learning environment, so that DELB I'm giving here. Okay, so here it is creating that dot DL hyphen ENV. So it will take some time to creating the virtual environment. Once the environment is created, then we are going to be using that environment to do executing the Python statements and all. Okay, done. So if you were able to do it, you can do it actually in parallel way. Will take some time. Yes, now it's completed. Environment is successfully created. But if you want to use this environment, we can use it. It depends upon the requirement and all. Okay. So now what do you do? So I would like to go with creating the Jupyter notebook. To creating the Jupyter notebook, we can click on the new file, and here activation, okay, activation functions code dot IPYNB. So the extension is IPYNB. I means interactive, PY means Python, NB means notebook. So when we are created, then you will get this kind of UI. So there we can have generate. So you can start generating the code with help of the AI also. Or else here we have a code. We can write the code manually with help of the click on this plus code, and so there we will be getting a box, and within the box we can write the code actually. So this markdown, it could help you to write some kind of description, maintaining some kind of documentation purpose. And so if you create multiple boxes, this all boxes want to be executed at a time, then we can use the run all. Okay. And if you feel it, you don't need this particular cell, we can click on the delete option, and you can click on the delete, and you can click on the delete. This is how you can create the code, or we can create the markdown, and we can delete it if you're not interested. Okay. As of now, that is fine. But if you want to be use this .env, so what you have to do here, we have a select option is there. You can click on the select, and here we have a Python environments. You can click on the Python environments. Here it could be listing the all the environments are available in your local machine. So just few minutes back, I have created the environment is Python, sorry, .dl env, right? Okay. So this is your current working directory which are available, so that you can select this one. So now we are using the Python 3.11 only, but the name of that particular version is I have mentioned here .dl env. Okay. So which means that we are going to be using the Python 3.11 only, but within this particular folder, which is not using your global environment. Okay, so it is a raw environment, so the libraries might available, might not be available. If you want to see that what are the libraries that are available, it's very pip library only is available. No one, no predefined libraries, no custom libraries, no uh, packages are available here. Okay, so if you want to use anything from the Python, then we have to install the libraries. That libraries will be keep storing into this particular location actually. The site packages are there, right? Within the site packages folder, the libraries whenever you are install it, and which will be come and store into this particular location. Okay, clear? Okay, so don't write the code inside of the .dl env. Most of the students will write the code inside of it. Don't write it. This .dl env, it could help you to use the Python, not to write the code inside of it actually. Okay, that is a just environment. Don't use any, don't write the code inside of the environments. Okay, I'm writing this activation functions code .pynb file in outside of this particular DLENV environment. Okay, fine. You selected the environment also, right? For example, I want to write the code here, or else I want to write some kind of markdown. So here I would write some kind of heading, then we can use the hash character activation a function. So if you want to describe, or if you want to write some kind of description activation function, it could help you to add okay, to add linear, non-linear, okay, non-linear, non-linear nature to, okay, or linear equation in a node in neuron. Okay, in node or neuron. We can call it as the neuron or we can call it as the node. So see, this is something like document. This is how we can write the document here. And this document, if you able to write, if you maintain this kind of document in your notebook, and after a few months or even your juniors or your teammates, if they see your code and they can understand what exactly the code, what it is doing and all. Okay, that is the purpose actually. So if you want to write some kind of description, or if you want here in Jupyter Notebook, as a data scientist or ML engineer, data engineer, we are always describe, or we always interpreting or inciting the results actually. Okay, so that is the reason we are going to be maintaining this kind of markdowns. It could help you to understand the results or to understand the programs. You can write your own notes. Everybody could understood actually. Is it clear? If you agree this point, can you please raise the thumbs up? But
Yeah.
any further questions? Okay. Now, so this particular session, I would talk about. I would like to go for build the code, or I'm going to be creating the functions for sigmoid functions and as well as sigmoid function, tanh functions, and softmax functions, and ReLU functions, liku-ReLU functions. I have explained various activation functions, right? Those functions which are already available inside of the PyTorch and Keras TensorFlows, Keras and TensorFlow or PyTorch. But I'm going to be creating my own logic with help of the standard Python programming language. Clear? So just for how the backend code has been created and all for that purpose actually. But you don't need to be create your own code and all because which are already available in PyTorch, TensorFlow frameworks. Okay, those things only we are going to be using, and especially for deep learning perspective. Hello.
Yes, Anya.
Okay. All activation functions, right? Okay. Okay. First activation function is sigmoid uh, max out, ilu, reguliru, tanh. Those are the things, right? Okay. So first, we'll start with linear linear activation. Also, we have linear activation function also. Okay, and so it could help you. Mhm. Yes. With example, 1 second, guys. So now let's start understanding of writing the code for various activation functions. And we are not using it actually. So let's start with the linear thing. Okay. So for example, linear means what? What does mean that linear? Okay. First, a linear activation function. So linear means, let's consider y equal to mx plus c. If something which is in this particular mx plus c, this kind of things, we can call it as the linear equation, right? Okay. For example, okay, so let's select the Python. Okay, yeah. So now a constant is constant means what? It might be a zero or anything actually. So our slope it might be one. If I consider my slope is one, then tell me what is the formula for this one? It's y equal to x only, right? Okay. To creating this kind of thing, so just taking we are importing the numpy. So this numpy is one of the library. It could help you to generating the numerical arrays and all. Okay, so here this is my input data. So I would like to go with creating the y. So this is this kind of linear thing. But this numpy which is not existed in your libraries areas. So what you have to do, and we need to be install it actually. So let's go and how do you install it? New terminal, and so we have to be okay here, right? Okay, yeah. So after if you want to install this activation this particular library in your environment, first we have to be activate that one actually. So how do you activate this one? Simply we can use dot followed by the dl and then um, a script and activate. This is the okay. So this is the command. It could help you to activating the your environment. Whenever you are activated your environment, whatever you are installing, it will be go on storing into this particular one. If you're not activated and if you're installing the libraries, it can be navigating to your global environment actually. Okay. To install this one, we can use the pip command, pip install. Okay, pip install numpy, right? So even if you're executing this above code, you will get an error. So you will get some kind of module not found error. Okay. So module not found error, you will get it. And moreover, when you're initially installing, which requires IPY kernel package, if it is not there, we can't use the Python in our Jupyter notebook. That is the reason we can install it. Okay, it's installing in backend and that IPY kernel, but still we are not installing the NumPy package. So which we are installing only iKernel package actually because it could help you to execute the Python on Visual Studio Code or else Jupyter Notebook on your Visual Studio Code. After installation of this one, we can start writing or you can start executing the code. Then you will able to get the outputs. Otherwise, you won't get it out. See, here it is getting some kind of installing the PY kernel, installing the collected package and all. Previously, we don't have any IPY kernel in our libraries. If you see it, so many libraries are installing because of this IPY kernel. It's automatically installing the supported libraries also. Okay. Just before 5 minutes back, we can see only few things, right? Now we are able to see many things instead of this slip folder. Okay, it's installed, right? And it's installed or not? Not installed.
You haven't pressed enter, I think.
No, no, I already did it. It's now rotating, right?
Still none.
It is still running it. Okay. Anyway, I would like to go for install the NumPy. This is the command to install the packages, and if you run it, it will be start installing the NumPy in our library. No, sorry, in
Now
our
it is installing, right?
that is different. So previously,
Oh, the
I
previous kernel packages by default is fine.
yeah, which is
That you
required
have.
to that I
Mhm.
executed, but NumPy I didn't, and just now I know I have done it actually. Maybe because when we are using those kind of things, it will take some time actually, but we have to use every time commands. That is a good practice in stuff, UI executions and all.
Yeah.
Okay, what we do, I can restart it again. Restart. If sometime if it's in a loop, then what you do, you just restart your kernel. Okay, so now it is, see, whatever the input we have it, that only we are getting. Those kind of things we can simply call it as the linear kind of stuff. Okay, so this is how we can use the linear kind of functions. But now what I have to do, I would like to go with creating
If
the
we print if we print a type of y, will it come as list or it will come as tuple
num
or
numpy nd array. So it's
ndr?
yeah, nd array, because we are using
Oh,
numpy, right? Numpy is one of the framework of the Python. So the data type of the numpy is nd arrays. So if you type of x, or if you type of a, then type of y, you will able to get it nd array. Okay, so it's not list or it's not tuple, it's a nd array. N means n, d means dimensional, array means array. It's a same type of elements. If you are collecting, that is array, right? So nd array means like one dimensional, two dimensional, three dimensional, it could be anything.
okay.
Okay, okay, now let's go for creating the sigmoid activation function Python function. So sigmoid, we are taking, we will get any input. That input, if you're applying 1 by 1 plus e power of np dot exponential of minus x, then it will be returns the sigmoid value. For example, the x values, I have four x values, right? Okay, sorry, 5, right? -2, -1, 0, and 1 and 2, right? So if I provide the values to this particular function, and then it is returning the this is one value, 0.111, something like this, and 0.26, and 0.5, and 0.731, and 0.88, something like this. See, if no one value is less than the zero and no one the value is more than the one, so that is exactly the sigmoid function is doing. So this kind
No,
of function inside of the neurons they were using actually. Okay.
no, the theoretical explanation of the sigmoid function which returns the value 0 to 1 is fine. But
Mm.
here, do we really need to consider how the calculation has been done by 1 plus NP, that expression? Or that NP dot expression is nothing but that NumPy package have
Exponential.
an exponential function
Yeah,
and which
yeah.
will calculate the
Mm.
values is
Yeah.
what we have to
Yes.
understand. That's it,
Yeah,
right?
yeah, yes. Because exponential calculation, if you use the standard Python, it will take a lot of time. So that is the
Mm-hmm.
reason they were using the framework. The name of the framework is NumPy. So the speed of execution is a bit speeder when you're comparing the standard Python. This is not a Python library. It's a package. It's custom package. So this package, this NumPy package, has been created with help of the C and C++, not Python. Because of that one, the speed of Python code is bit faster. But generally, Python code execution is slow. But because of that issue, they were using various custom packages. And the packages
Mm-hmm.
are creating with help of the C and C++ so that the speed a bit faster when you're comparing with the standard Python. Okay. Yeah. It's a bit,
Okay.
it's exponential. And now, tanh. So inside of the NumPy, we have a tanh function is there. Okay. So np dot tanh, and we can provide any value of x. Then it could be providing the minus c. You will get the values between -1 to +1.
Mm-hmm.
Okay. So np, the numerical Python, he is having the tanh function also. This tanh function only we are using as an activation function in the neuron. In it's as per your requirement. No, I'm not saying every time you should use tanh.
Yeah, yeah,
But
got it.
okay, so and meanwhile, if you want to create the ReLU activation function, there also we are using max, right? NP dot max maximum. So maximum is the function. So this function which automatically identifying which value is the maximum between these two things, and that maximum value only it is returning. So that means backend which is checking these two 0 and x, if which one is the bigger, then that value is returning back. Okay, so that is the reason we are getting the 0 0 0 1 and 2. See, because in x we can try to print the x -2. So if you compare the -2 and 0, which one is the bigger? 0, right? 0.
Mm-hmm.
And if you compare with -1 and 0, 0, right? Okay, if you compare with the 0 versus 0, 0 only, right? And if you compare with the 0 versus 1, 0 versus 1, it's a 1. So that is the reason we are getting the 1 over here. And if you're comparing with uh, uh, this 2 versus 0, the maximum value is the 2. That is the reason we are getting the 2 over here. Okay. So this is the values we will get from the ReLU activation function. So this ReLU activation function is using behind this particular logic only.
No, but why it is giving 0, 0 different negative values?
See, because we are using the maximum, right?
No, no,
Maximum.
maximum 0 comma x. The x first value is 0.
So no, no. Here x values are
Oh,
no, no, just
minus.
okay. These are the my x values. Okay.
Okay,
First,
okay.
uh, if you give this x, which is not entire values actually, one after one. First, it will take the -2. So minus
Yeah, yeah.
2 in place of x -2. 0 versus -2, which one is the maximum? 0
0.
versus 0. That is the reason we are getting the 0 for first element. So for second element, 0 versus -1, 0 is the maximum, right? Because we are
Mm-hmm.
applying the maximum function. 0 versus -1, between those two things, maximum value is the 0. That is the reason we are getting 0. And my x value is the 0. And if we compare with the 0, so from the 0 and 0, which one is the maximum? Both are same, right? That is the reason 0. But when coming to the fourth element, it's a 1. And here comparing the 0 versus 1, from these two things, maximum value is the 1. So that is the reason we are
Okay.
getting this print function which is executing this logic. Okay.
Okay, got it.
Okay, this is exactly a ReLU activation function. And so in neurons, we can use this kind of logics actually, but you don't need to be go with creating this activation functions and all. Okay, we'll see those examples also. This is a ReLU. So for there, we are applying the where clause or where function. So this is your alpha value. Whenever your x value is a negative number, whenever your x value is a negative number, then I can multiply with the 0.01. So this alpha value, it could be anything. You can use 0.1, or we can use 0.02, we can use 0.00001, we can use 0.009. It's up to you what value you want to use it. Okay. So it is checking this where condition, which is available in numerical Python, which is checking my x value, my x value is greater than 0. If my x value is greater than 0, then I can return the x. Okay. If in
Mm.
case my x value is not greater than 0, then I can return the alpha into x. Okay. So here we have three things are there. So first one is a condition where it is checking this condition. If this condition is satisfied, the first element it could be written it. If condition is not satisfied, then it could be written this logic.
Mm, yeah,
So
got it. If
from
condition,
this,
but
yeah, kind of if,
okay.
kind of if, okay.
Mm.
If this condition is satisfied, then it will
Then
be
return.
returns. If
Yeah.
this condition is not satisfied, then it could be returns actually. Instead of writing the if and else, then we can use the where in numerical Python. Okay, it's very simple, right? We don't need to waste too much lines of code and all. So in a single line, we are doing these things actually. So this kind of things simply we can call it as the um, train trinary trinary operator or ternary operator, something like this. Okay,
Okay, that
see,
0 dot 1 dot is the output which it returns, the set like that.
no, it is
It was
multiplying.
okay. So
Okay,
what is
see
the
here,
output of that 0?
see,
Why it came 0 dot?
yeah, I will explain, please. Alpha value is 0.01, right? Okay,
Okay.
it's up to you what value you want to keep it. For
Mm,
example,
mm.
these are my x values. These are my x values. So if in case x value -2, okay, -2 greater than 0, condition fail. If condition
Yes.
is fail, then which is try to execute this logic.
Mm-hmm.
Alpha into alpha value how much? 0.01, right? 0.01 into 2. 0.01 into 2 how much? 0.02, right? So
Mm, mm.
minus 0.02. And now uh, will we go with checking with this one? How many elements we have it? That many times this condition will execute. Okay, so for example, -1, right? So -1 greater than 0, condition fail, then this is the logic will execute. Alpha value is a 0.01, x value is the -1. -1 into 0.01, it's a minus 0.01. Okay, and for the third element, it is also completed. My third element is 0. 0 greater than 0, condition fail. If condition is fail, then it will be executing this one. So alpha value is the 0.01 and x value is the 0. 0 into something 0. That is the reason we are getting the 0 point. 0 point means it's 0 only, right? Okay.
Yeah,
So
why that 0 point is the question. 1 point, 2 point. When
because
we are multiplying
the
with the
output,
factor,
the
you're saying decimal.
yeah, but by default, the data type of these things, it could be a float.
Okay, the
Uh,
output of the previous result sets of that sigmoid function, or what can I take a look at output? Okay, there also they are coming with the dot only. No,
no.
little bit above.
No,
Little above. Okay, no.
because here we are they're using
Dot.
maximum, right?
Mm,
Maximum
mm, mm.
decimal we are getting because we are using maximum function here. Okay. If for example, if I'm using the zero point 0.0 here, then let's see.
No, no, this I
No.
understand. Yeah, now you are
Try to
getting it.
understand. See, here I'm using the data types. All here I'm using the data types is integers in my
Mm.
function. Okay. In my function, I'm using data types are integers. So that is the reason I'm getting the values. For example, if I'm using the single dot, because it's an array, all elements, it should be same data type. It doesn't matter whether it is integer or float or something else. Because of that one, here I'm using maximum is 0.0. Okay, and comma x. Even x value is the decimal number, and but one of the number is a float, then automatically all the numbers it could be a float only. Okay.
Mm.
Okay. And but here it's your here alpha value is float, right? Here
Mm,
alpha value
mm,
is a float, right? If you multiply with float with something, you will be getting the float. If any one of the
mm,
value is
mm,
the float, the remaining all values also it could be the float, because the functionality of the array is, and so same similar type of elements it can be collecting, that is called array. So list
mm,
tuple it is different. Dissimilar data elements we can collect it, but in case of array, similar type of data type only, similar type of elements only it can be collecting homogeneous data. And if
mm.
one element
Okay,
is a
okay.
float, if some second element is the integer, then it is not array, right? Array means all it should be either integers, all it should be either float, all it should be either complex, all it should be string. Okay, if one element is string, if one element is integer, it won't work well. Okay.
Mm, mm.
So, but you're multiplying with a float and something, then definitely the output it could be the float. If one element is a float, then automatically all elements also it could be the float.
Yeah, it should be because I got it. Because of the array having same data type of elements. Okay,
Yes,
got
yes,
it.
yeah, cool. Oh. Now, I hope you understood how the Riku-Relu function is working, right? Okay, so behind this one is
Yeah.
we do have ilu. Ilu is also one kind of activation function. I have mentioned only few functions, but we have ilu also, ilu activation functions. And so here also, if x value is the greater than 0, okay, and it could be returns the x value. And but in case of ilu, which is applying the exponential alpha into e power of x minus 1, alpha into e power of x minus, you understood what is the functionality it is?
Mm,
Okay, alpha into e power of minus e power of x,
minus
e
one.
power of x into minus 1.
So it will come always negative result, huh?
Yeah, it always it could be negative, because whenever x value is the negative, then it could be the negative only.
Mm, no. The above equation what you wrote, e power x into minus 1, there might be, but how it is defined internal, I'm not sure. But when you are multiplying anything with minus 1, the result will be minus 1 only, right? Minus
Minus
negative
1
value
only,
only.
minus 1 only,
Mm.
but see here minus 0, some constant value you're multiplying, nothing you're applying actually. But here minus 0.86 and minus 0.63, 0,
Mm-hmm.
1, 2, something like this. Okay. See, but here we are getting 0.02, 0.01, some common value you are just multiplying, right? Some constant value you are multiplying. When you are multiplying with the constant value, it seems like some it's not exponential. It you will get the curve something like this. I can show you the curve how it will be looks like. Mm, yeah, see, this is your data, right? For example, if
That is why.
x values
Yes,
are
okay.
positive, then it could be linear. If x
Mm-hmm.
values are negative, then it could be linear, but kind of this thing. Okay. But when you're applying exponential kind of thing, it is a linear only. In whenever your x values are positives, but whenever x values are negatives, then it could be kind of exponential kind of thing. Okay. So it is not linear in negative values. It is not linear for the negative values. It is exponential for the linear values. But here for negative values also we are getting the linear equation. Okay.
Mm-hmm.
For negative values also we are getting the linear equation, but bit of uh, slope is small. But when coming to this one, for negative values, we are getting exponential equation or exponential curve. For positive values, we are getting the linear value. So that is where it can be identifying the nonlinear nature data also, ILU activation function. Okay.
Okay.
And when you're applying that alpha value, if it is a very small value, then which is closely towards to the zero only, right? That is not that is not that is not learning much, and vanish we are getting vanishing gradient problem, or else slower convergency. It might be a chance, and the learning also it could be less.
What is the
Latency.
gradient, the terminology gradient to this functions?
That's good. Let me explain you. For example, we have inputs, right? Okay.
Mm-hmm.
And these are the neurons, hidden neurons. Okay.
Okay.
And this is output. And just imagine, okay, these are the inputs, and we are having some weights, and we are feeding to all the neurons. This architecture, you already know it. And
Yeah.
these neurons will produce some output, and this output it could be input for this output neuron, and
Mm-hmm.
the output neuron it could be produce some output. Okay,
Mm-hmm.
right? So what I'm doing actually, I would like to be go with the plot this loss. I would like to plot this loss corresponding weights. Whatever the weights I have it, whatever the weights I have used initially, for this weight, I can plot the loss. Okay. After that one, what I'm doing actually, I can do the back propagation. When I do the back propagation, when I do the back propagation, so what I'm doing actually, I can update the new weights in different strategies I can apply. I can update the new weights. Again, again, I can send the same inputs, and so the neural network can learn, and again, it could be producing some output. This output again, I can plot on top of my uh, gradient descent. This kind of graph, we can call it as a gradient descent. Okay, JD, gradient descent. And you will get some kind of loss, and the loss we are plotting on top of your gradient descent plot. And again we do a back propagation, and again weights it could be updated. Again we are giving new inputs or same inputs. Again we are getting some kind of loss, and the loss we can plot it. Okay, so this plots, if you plot it at one particular time, the loss it could be minimal. That kind of things we can call it as the global minima. Okay, this kind of thing we can call it as a global minima. So whenever it is reaches the global minima, maybe the weights it cannot be updated, or else even it is updating the weights, maybe the loss it could be increases. Okay, so this kind of strategy, or this kind of graph, we can call it as the gradient descents. And we can find the slope. That slope we can call it as the gradients. Slope only we
Mm.
can call it as a gradients. Yeah, that theoretically it's this thing actually, but
No, no, I'm trying to correlate in my mind that, yeah, partially I understood. I can't say I totally understood, but okay. So the whatever the global part when we reach, so that means whatever the
global
inputs
minima,
you view,
global
irrespective of the inputs, you already met the global minimum.
yeah,
That means the output will never change.
output, not output actually. Output performance is good.
Performance is good. Okay.
Mhm. Output can be changed, but performance is good. The weights, it could be, uh, we won't change whenever it is reaches the global minima. We don't know whether it is
Mhm.
reaching the global minima and all, right, until unless
Mhm.
weights keep updating. So it can be reaching that local minimas as well. Okay, this is also, you feel it, it is also global minima. You feel this is also
Mhm.
global minima. You feel this is also global minima, but it is not exactly correct, right? Okay, because
Okay.
global minima is this one, right? These are all local minimas. How do you identify this is a global minima and local minimas? With help of the slopes, we can find the slope of this particular things, and that is
Oh,
where
okay.
okay. So our global minima, when this from this particular point, you might have some weights, right? Those are the weights are useful weights. Okay.
Mm.
Yeah, so that is a too early to explain this one. I have to be again I can explain you after activation function, optimization, how weights are updating, and so how you can use the gradient descents and all, and with help of graphs I can show you. No worry. Hmm? Just this particular
Mm.
time, which is here also we are getting linear kind of output only. That is what my question. That is what
Mm.
I'm understood. So even I'm getting some kind of negative values, that particular situation also I'm getting some kind of linear curve. So which is not fully adding the non-linear nature. So that is the reason I'm applying the exponential function. Whenever I'm applying the exponential function, maybe you will get this kind of curve. So this is a non-linear nature. Completely you are adding uh, for your data or for your inputs. Okay.
Okay.
Yeah. So just even you don't need to keep everything in your brain. Just remember these function names: ilu,
Yeah, yeah.
ligu relu, and relu, tanh, sigmoid. At least how to recollect these function names, and you can Google it also. What is the difference between these all functions, and you can definitely understand. Okay.
Yeah, I already did yesterday. That's why I'm catching up your class at least today. But anyways, yeah, once we come to the practical, then we'll understand a little bit more clarity then.
Yeah, so this is the softmax function, and
Mm-hmm.
so x np dot exponential of x minus np of max of x. So you might have the multiple x values are there, right? From that one,
Yeah.
you will get maximum x value that we can subtracting from your x value, okay, xi value. So that is your exponential term. That exponential term by b np dot sum of exponentials of x. So these are the function for the softmax, and it could be producing the some values. See here, this is one value, and this is one value, and this is one value, right? So you're providing this course like 2 1 and 0.1. When you're providing the 2, then we are getting some max value, and when you're providing the 1, so some value you are getting. When you're providing the smaller value, we are getting the small value, something like this. For example, you can give it minus 4, or you can give it minus
Mm.
5. So see, this is mm, see, it is e
So
power.
it's
There is a
negative
negative.
e
There is
power
no neg.
exponential.
It's
Oh,
exponential.
yeah.
E power 0.00001, something like this. This is 0.0004 0.00005. Okay, so in softmax
But
and
but what is sum to one? The softmax is used for the multi-class
mm,
classification, right?
mm, yes,
Then, but it sums to one is what I see. But like, what is the meaning of softmax function sums to one?
sums to one. I didn't get sums to one.
When I've gone through the softmax function functionality,
Mm,
it said like anyways yesterday as you said it states that our multi-class classification problems, right?
yeah, softmax is useful for multi-classification. Okay,
Yeah.
and sigmoid, it is for sigmoid. Sigmoid is for binary classification.
Okay.
This is for multi. Okay. So based on the here we are getting some probabilities, right? So the probabilities range, softmax will getting some vectors and all. Yeah. So
Okay.
whenever I use multi-classification problem statements, then that time we'll see that how the softmax will works in real time. So as of now, you can
Okay.
just feel it. Softmax and sigmoid is useful at output layer when especially for classification problems to solve. Okay,
Yeah. Got it.
so these are the coding part of this particular things, but these are the functions we were created our own. Okay, but what I
Mhm.
would like to do, we would create our own um, what we call mm, neural network. Okay, how do you use this
Okay.
these things with help of TensorFlow and Keras? For that one, we can have the TensorFlow. Okay, so TensorFlow, and so there we have to import the sequential, and so this dense it could help you for to add the layers. Okay, so these are the sequential to creating the architecture, deep learning architecture. Then we can use the sequential because one a layer output is input for the next one, right? So that output it could be input for the next one,
Oh,
right?
okay,
So that is a
okay, okay.
sequential. So
Straight
that is the
line.
reason, yes, sequential.
One to one
Yeah,
mapping. Okay.
yeah. So that is the reason we are using the sequential, which is available in the TensorFlow. And inside of the TensorFlow, we have the Keras, and there we have the models, and we have to import the sequential. So this sequential, it could help you how many networks I want it actually. So dense means neurons, how many neurons you want to be created. I want to create the 64 neurons. Okay. And each neuron, it have the activation function is the ReLU. Okay. And my
Mhm.
input size is like, 10 inputs only I can receive it. I have 10 inputs. First layer, this is my first layer. The first layer having the 10 inputs. And uh, first, this is
If
my
you have
input
10
layer.
in, okay, okay, go ahead. Sorry. Yeah.
This is my 10 inputs. This 10 inputs, it will be feeding to the 64 neurons in the first hidden layer.
Oh,
Okay.
okay.
So how this architecture will create it actually. So these are
Yeah,
the
that's
10,
what
right?
I'm about to ask.
So
Yeah.
this
Diagram
is 10.
better.
This is
Uh,
10. This is 10 inputs. Okay. Or else don't, you guys are a bit confused because for inputs also, if
mm,
I'm using the circles, then you might be getting some kind of, doubt and all, right? Okay. X2, X3, and so on. X10. I have 10 inputs. Okay.
mm-hmm.
This is the something like this. And 64. That means I have 64 neurons. For these are my 64 neurons. Okay.
Okay.
This is my input layer. This
To
is my
each
input.
neuron, you are submitting 10 inputs.
E for each. Yes, right. So
Okay.
this one, and this one, and this one, and something like this. Okay.
Okay.
Whatever
Okay.
the
Okay.
inputs we have it, the 10 inputs, it could be input for this particular neuron. Okay.
And the
And
first
this,
layer is taking the activation function of ReLU
yeah, this first
for
hidden
every
layer.
node,
Yeah, for
for
every
every
node.
neuron.
Yeah. Yes, for every neuron, and every layer having one activation function only.
That's what my next question. So you can't use the combination
Yeah.
of activation functions
No,
by
in a
layer
single,
wise
yeah, no,
in a
in
single
a
layer.
in
So,
single layer we
okay.
can use same, in single layer we can use same activation function.
Activation
But
function. Okay.
what you do in a next layer we can use a different activation function. If you want to
Yeah, got
use,
it. So,
but
mm,
once if you're creating one neuron, hidden neuron, within the hidden neuron, all the neurons are having the same activation function. Okay. So, and
okay.
this is one layer you created, input layer you created, and first hidden layer is also you created. In second hidden neuron, I have only 32 neurons. My second hidden layer having only 32, and my
Mm,
last
mm.
layer having only one neuron. That is my
Which
output.
is output. Yeah,
Yeah, my
got it.
my output I have
Mm,
used different activation function, that is sigmoid. Okay. But
mm, mm, mm.
here I have used ReLU. Here I have used ReLU. If you want to use Liku ReLU, you can use. If you want to use ILU, you can use it. If you want to use softmax, we can use it. If you want to use TANH, you can use inside of the neurons. This is how you're going to be creating this particular architecture with help of this sequential.
But where we oh, you can you do undo that once? Control Z. You can't do
Hmm.
it.
Hmm.
Yeah. So from where we have defined from hidden layer to the second layer, third layer, second
Sorry,
layer. So how we are passing the inputs?
we are not defining. It is a sequential. This sequential is
No, no, no.
automatically,
That means
see.
all 10 inputs will go to the same, the 32 layer neurons.
Oh, no, no, no. You're a bit confused here. Let me
So
explain
the
this
first
architecture.
layer,
Yeah,
you
yeah,
have
please.
passing 10 inputs. Got
Yeah,
it, right?
let me explain.
Okay.
So here I have 10 inputs. Okay,
Okay.
I have 10 inputs.
Mm.
How many inputs I have here? 10 inputs, right?
Then, mm.
And uh, my first hidden layer, how many neurons?
64 neurons.
So this
All
is
are
my,
having RLU functions. Okay.
these are 64. Okay, and
Mm.
my
Mm.
next neuron, how many? Next layer, how many?
32.
32. Okay, and my next neuron, how many? Near layer, how many? It's only one, right?
1. Mm. Mm.
This 10. Let me consider this is one neuron inputs, right? Okay. So here I have 64, right? Okay.
Mm-hmm.
64, right? Okay, 64. See, this first input, second input, third input, till 10 inputs will be one neuron. Again,
Yeah, got
this
it.
first input, second input, third input, and fourth input till 10 inputs, it will be go for second neuron.
Second one.
And here I have a 64 neurons. Each neuron,
Mm.
it will receive the 10 inputs. Okay.
Yes, yes, got it.
And my second, my third neuron, I mean, my second hidden layer having only 32.
Mm.
This
Mm.
first, let me consider this is my first neuron. This first
Mm.
neuron, it will be receive the input from the 64 neurons.
That is what. So we don't need to define, but that is by default architecture.
Yeah, by
That
default
means
or
the first hidden layer, how many neurons are there? That many inputs you are passing to the
next.
second hidden layer for
Yes,
each
right.
neuron. Yeah, that
That
is
is
what my question. Yeah, got it, got it.
yeah. So here also 64 inputs. Here
Mm,
also
mm,
64
mm,
inputs.
mm.
Here also 64 inputs. Like this 32 neurons, each neuron will be it will be receives the okay previous hidden neuron. How many neurons we have it? That many inputs it can be receive
Inputs
it.
will be received. Yeah, got it.
Yeah.
I got the
My
answer.
my
Yeah.
last output layer it can be receive
32.
only 32 because my previous layer having only 32 neurons.
32 neurons.
So it
Okay.
can be receive only 32 neurons, 32 inputs only. Okay. And my output it can be produce only one output because I have only one neuron, right? Okay. So that it can be produce only one value, but the value it may be between the 0 to 1. Okay.
Mm, yeah,
Any
got it.
questions, guys? Any questions regarding about this one? And automatically the connection sending inputs and updating, adding weights and all, everything will be taken care by the sequential only. And if you want to see that, how the model summary and all, as of now, we were not training any input. We are just creating architecture. But if even if you
Mm.
want to create the architecture and um, you should have TensorFlow library. Okay.
Yeah, that is
So
what
if
I'm about to ask next question. So from TensorFlow is a library, Keras is a library, or models is a library. What is that? So inside. So import
okay.
following with is a package or like
Yeah, see,
module or.
TensorFlow
Mhm.
is one library. Okay. So
Okay.
this library, it may have the multiple libraries also.
Yes. Okay.
Okay. Like this, in TensorFlow, we have the Keras is one of the sub library. And inside of the
Mm-hmm.
like it is also one library, right? Inside of the library, one more
Again, we'll have sub libraries. Okay, it's a
library or
models. Okay.
functions,
Okay.
or it could be anything like this. Okay. So if you want to be access this kind of granularity, then upper library dot, library dot, and sub library. That is how we can access. Inside of the models, we have one class. The name of the class is sequential. And in same way, in Keras also, we have the another library that is the layers. Inside of the layers library, we have a dense function or a dense class. So the
Is a
use of
class or
this,
package?
no, this sequential and dense are the classes.
Okay, we are just
Sequential,
importing classes.
yes,
Okay.
we are just importing class, sequential class and dense class from the models, from the layers. These models and layers are available in Keras. This Keras is available in TensorFlow. So if you are
Mm.
installing the TensorFlow, then automatically this everything could be installed it in our libraries
Okay.
uh, environment. Okay. So
Okay, got it.
let me import pip install.
I'm not sure either I'm not giving chance to others or everyone don't have any questions and I only have.
No problem for asking everyone questions.
That's good.
Yeah, so we are installing the TensorFlow, then which is installing the latest version 2.2. Before TensorFlow 2 version, we have TensorFlow 1. The TensorFlow 1, we don't have any Keras sub-library, okay, which is available in a individual library. Keras is itself, it's a one individual library. By the time we have to install the TensorFlow, we have to install the Keras, then we can use this kind of logics and all. But in a current version of TensorFlow, inside of the TensorFlow only Keras is already existed. Then you don't need to be installed the Keras separately.
Okay, got it.
As of now, we were not trying your neural network. We are just creating the architecture. This is how we are going to be creating architecture. If you see the summary, you will see this how first layer, how many inputs are there, and second layer, how many neurons are there, third layer, how many neurons are there, fourth layer, how many neurons are there. At output, what is how many neurons we have it, and what activation functions we are using. That kind of summary you will able to see with the help of the summary function. But as of now, this TensorFlow uh, library, which is not available in my current environment, so that I'm installing it. So if you're not installing, if you're not installed, and if you try to be executed, then you will able to get the errors. See, it is a
Mm.
very big package because,
That's
and
what it's
moreover,
taking time.
when you are working with the deep learning, don't use minimal computational power laptops. It may be affect your speed of your computer. Okay, don't use it. At least we have to use the Google Colab. Okay, don't use
Oh,
local
okay.
environment. I'm strictly warn it because I in 2019, 2018 that time. I bought one laptop and I started building a model on my PC. It is kind of
It
image
crashed.
process. It's not crash and automatically it was slow. Like the speed of the processing speed was reduced. If I open something, it is opening in one day. At least generally we feel it. Our computer speed was reduced. We feel it actually. Okay.
Yeah, yeah, got it.
Don't feel if you don't want to feel that kind of thing as I'm instructing, I'm warning to you everyone, use Google Colab if you want to create this kind of architectures because your Google having GPUs also free GPUs. It won't use your CPU. It can be used
Mm-hmm.
GPUs and all. Okay. Google Colab, you can Google it, Google Colab. There
Yeah,
also you
yeah.
can create this kind of notebooks.
So we are taking break tomorrow, right, Anya?
Yeah, enjoy the
Yeah. Enjoy
2026.
the 20, 2025 last day. Hmm.
See,
Oh, I
it
mean, in
seems
India, it
like
is today. Yeah, it's today, tonight. Yeah.
today is the last. See, automatically this TensorFlow, Keras, Rich, Tensor Board. This Tensor Board, understand what exactly Tensor Board is doing it actually. You will see that
Mm-hmm.
the boarding the architecture graphically.
Okay.
Request Google pass the H5PY Markdown URL MLD types. And these are the different libraries we were installed while you're installing the TensorFlow. Automatically, it is taking care about it. These are the dependencies libraries, okay, to work
Okay.
TensorFlow effectively. Sometimes, if nothing, if maybe depends upon the Python version, you have to use the corresponding library or framework. For example, if Python 3.6 or 3 point older version, if you're using, the latest versions may not
Mhm.
be work. Okay, so before you are installing something, and we can cross verify this version of TensorFlow whether it is supporting my current version of Python or not. If it is not supporting, then we can try to use that latest Python version and the latest TensorFlow versions. Then you won't get any kind of problems.
Okay.
As of now, I'm not trained my network. I'm just creating the network as of now. But to creating this network also, we use it's just bits, just the 5 to 6 lines of code. Nothing will be there.
Mm.
Last week,
But that's a
whatever I
complex,
explained.
complex architecture, right? 64
Yeah.
nodes and then, yeah.
Yes, yes. We were
But did we
not worried.
define the, no, we haven't defined the RLU functions, right? Just we, uh, what we can say, we
We are
haven't given the definition of the RLU function or the
Yeah, no
expression or the
problem. No,
calculation.
no problem. The TensorFlow is inside of the models or inside of the
Mm-hmm.
sequential. This all activation functions are already defined it. Okay, so sigmoid function definitions, relief activation function definition, everything has been
It's a
created
predefined
inside of,
one.
it's a
Predefined.
predefined
Okay,
inside of
okay,
the
okay.
sequential. We don't care about the logic, whatever I explained previously, but how it is working in the sense, behind this particular sequential class, this kind of functions already existed. So that is the reason we were not
Then why
worried about.
again, like when we see the dummy programs, we have imported our NumPy package, right? So that
Yeah,
also have the same kind of
yeah,
functions you.
yes,
Okay.
yes, right.
Okay, okay, okay.
Inside of the TensorFlow, they were importing the NumPy. Okay.
Yeah, obviously I got it that I can correlate.
Yeah, even you
Mhm.
can see the code also. Once if your libraries are available, you can view it, the code part and all. Okay, no worry.
Mhm, mhm, mhm.
You feel it, like you feel it, you created your own way.
Still it is creating or it's done?
Creating, it's installing. TensorFlow is installing because it's a very big package.
So this is one time, right? So your environment is always
Yeah,
available to,
yes,
yeah,
yes,
this
yes,
is
right.
one time.
That's true. It's a one-time environment. Once if you're creating an environment and if you're installing the packages, it could we can use it whenever you want it actually.
Okay.
Yeah, done.
Mm, yeah.
Okay, so now we can run it. So which is running? Don't worry, it's architecture. You're not training your model, no problem. Okay, when you're training the model and if your
We
data
have to
set
give the
is very
inputs, right?
large, yeah,
Okay.
when you're giving input and if your input size is already defined 10, right? You can
Mm.
give only 10 inputs only. If you try to give the 10 or 11, 12, then you will get an error. You create
Oh,
architecture
okay.
in such a way and you're providing that in an input size is
Oh,
different
okay,
value,
got it.
then it could be the problem, right? Okay. See, here you can see how output shape. So the layers, okay, first dense layer. So parameters, these parameters are your weights.
Oh, wait. So, okay.
Okay, so dense one, there are 32 output. This is
Mm.
output shape. So it could be producing 32 outputs in second layer. In first hidden layer, output shape is 64.
Mm.
Output is 64. Don't worry about input layer. Input layer is 10. It won't display here. This is my hidden layer 1. This is my hidden layer 2. And this is my output layer. Okay.
Okay.
My first hidden layer, it can be producing 64 outputs. My second hidden layer, it can be producing 32 outputs. And my third hidden layer, it is my output layer, which is producing one. Just it is our understanding. We are giving like layer one, hidden layer two, output layer, input layer. But it can understand it's a dense layers, dense layer one, dense layer two, something like this. Okay,
Mm.
and there are 704 parameters. These are learnable parameters. Automatically, the model it can be learned set actually. Okay, these are the 2008 parameters, params. These are the params. Total it is 2817 and trainable. Out of this one, there are 2817 parameters are trainable and zero are non-trainable. So these are all parameters are trained from your data. These parameters it automatically train it when you are applying the input, when you are feeding input to your network. Okay. So
Okay, what is
just
the size?
size, what size, which size?
KB.
11 KB.
Yeah, yeah, no, but like, what it has the value or what it is
It
meaning.
can be it can be anything. It's variables, right? Which is generated. It's a parameters, right? Parameters means what? Which can hold some value. Okay.
Values, okay.
So when you're holding some value, it has to be required 11 KB of your memory to store
Memory,
this.
okay.
Yeah. So the data only that parameters we can use it when you want to predict something or when you're applying some unseen data on your network, then that values automatically producing output actually.
Okay, got it.
Okay. Okay, cool. That's summary of this one. And I hope even if you're not understood, don't worry, and I can explain you later on those things. Okay, clear, right? Yeah, that's
Yeah,
for
yeah, clear.
today's session, and let's continue tomorrow for more information.
Not
Not
tomorrow,
tomorrow.
right? Today we are
Day after.
taking off.
Yeah, yeah, yeah. Day after tomorrow.
Yeah, yeah, yeah.
Chalo.
Okay,
Thanks.
thanks.
Bye.
Thanks, bye.